Hello, everyone. Good morning, afternoon, or evening, wherever you are. Thank you, first of all, for coming here and joining this session. And thank you to Codementor for inviting me to speak here. Um, while I speak, if you want, you can ask questions in the chat, and I'll also leave some time for questions afterwards if you like. So let us begin. Hi, my name is Omer. I'm the CTO and one of the co-founders of Swimm. I'll explain a bit about Swimm later, but mostly today we're going to talk about documentation and knowledge sharing in general, especially when it comes to code. And we'll talk about a solution using code-coupled documents for modern systems. But to start off, I'd like to start with a personal story. So this was around 3 years ago, where Gilad, one of my co-founders, and I sat, and we were sitting in a cafe in Tel Aviv, and we're sipping our coffee. And at some point, the waiter came to give us food and also drinks. So the waiter came, and he also came with another waitress. So this is one of these situations where you have the waiter who is a junior waiter, a new person in this field, and there is this waitress, the senior waitress in this case, who is supervising him and also supposed to provide him guidance and help. So the waiter came to us with this tray and a few drinks and also plates. And as he was walking with this tray, he suddenly froze. He looked at us and looked at the cups and looked at us and looked at the cups again. And the problem we later understood was that he had cups that were put on top of these coasters, and he wasn't sure he was supposed to unload the cup. Was it the cup first, then the coaster, then the other cup, and then put the cup on the coaster, or maybe another way? He wasn't sure, so we just froze. And then the senior waitress, I'm almost automatically saying senior developer here. The senior waitress was doing something like, and she just grabbed the cup and the coaster together and let it rest on the table very gently, and gave him the look of like, who hired you? Now, Gilad and I talked about it afterwards, and we really wanted to create this T-shirt for this poor guy. So we wanted to give him a T-shirt that says, "I'm not stupid, I'm just new." I mean, I'm pretty sure this guy could put a cup and a coaster on a table, right? He just wasn't sure how it's done in this specific place, in this specific cafe, what their standards are. And that got us into thinking and talking a lot about knowledge transferring in general and how that happens. So with that, again, today we're going to talk not about waiters in general, but about documentation, why it's broken, and provide a solution. So first of all, I'm sure we would all agree that understanding code happens all the time as developers. So it happens obviously when we onboard to a new team or to a new project, obviously to a new company. That's where we have to get to know a lot of new things in a very concentrated period. So in a few weeks, a few months, we have to get to know everything from scratch, or a lot of things from scratch. But onboarding is just one case. We get to understand a new code area almost every day. So it could be while we're debugging someone else's code. It could be while we're performing code review. So someone create a new code. It's new for him, but now it's all obviously new for us, and we need to understand it and read through it. Also while debugging our own code or someone else's code. And basically, as we know, modern systems become more and more complex, especially since we introduced microservices, which have lots of advantages, obviously. We have a lot of services, different languages, different technologies we have to get to know, and different people get to know different parts of the system. Now, having a modular system is an advantage, of course, but also it creates knowledge silos, wherein some people can understand and know some part of the code and not know other parts of the code. So how do we handle it nowadays? So basically, there are two ways to handle those knowledge silos. One way is just to throw you into the water. Let me not block that from view. So let's say someone joins our team and we want them to get to know the code really well. So we can just throw them into the water and tell them, good luck. You can either sink or swim. By the way, that's why we called our company Swimm. The other way that people sometimes refer to is, well, read the documentation, right? There is some documentation, read it, and again, good luck, go swimming. Now, the thing with documentation is that it's completely broken nowadays for various reasons. And documentation is actually one way from the existing ways to share knowledge in general and sharing knowledge about code in particular. So, what are those current ways that we have to share knowledge, and why are they not efficient? So one way is clean code, and I get to hear that quite often. People tell me, okay, but I don't need to document my code. I don't need any additional explanation. I'm an artist. I write amazing, super clean code that everyone can easily understand. And actually, that poses a question, right? I mean, let's say there are some great developers out there that write very beautiful, very clean code. And the question is, can clean code tell the whole story? Now, intuitively, if you think about it, last time you got into a project, you probably remember that was a long and cumbersome process. And perhaps not all the code that was really clean. But even if let's say we had a function that was very clear, then it was clear in isolation, right? So if we look at a specific function, a specific class, even a specific module, it can be very clear on its own if the code is really clean. But even the cleanest code doesn't explain flows. It can't tell me what happens when this function is called from one file or another file, or in other cases, from a whole different repository. And I don't even know where the code that calls this function resides. It's even maybe in a repository that is not currently cloned to my machine. Another thing that clean code doesn't tell us is design decisions. So while we were planning how to implement this module, this class, this system, we had lots of discussions usually. It could be among ourselves, so maybe discussing with ourselves, either or vocably or maybe mute, but we thought about things. Or we had a discussion with some teammates. And in those discussions, we made some design decisions. We decided, for example, that this should be a class because of this reason. And we may want to make sure this function is only called in this way for those reasons. And those decisions are not always encapsulated within the code that we implement, especially the decisions we made as to what not to implement. So, for example, we decided to implement a function in one way and not another way, then this alternative way that had some disadvantages we thought about is not implemented. So it's probably not even written why we didn't choose this way. So this is something that clean code obviously cannot tell. Also, there are other things that are not in the code. For example, configuration values. Sometimes it could be on a database somewhere, configuration values on another repository, and of course, many other things. So clean code is important, obviously. It's something we need to strive for. It's something we need to make sure we get to write clean code all the time, but it does not tell the whole story, and therefore is not a good solution to transferring knowledge on its own. Another pretty common way to transfer knowledge is giving lectures. So actually having some people in a room and giving a talk, like the talk I'm giving you right now. So giving lectures can be helpful, at least sometimes, right? But, well, if the lecture is not recorded, that is, we give it, let's say, one-on-one with a new developer who joined the team, or maybe to a bunch of developers in a conference room, and it's not recorded, then it takes a lot of time, because next time someone joins the team, I need to give that lecture again and again. So it would take a lot of time. On the other hand, if it is recorded, then obviously it gets outdated. The code quickly evolves, the lecture stays behind, and what we currently have is a recording of a lecture that is not 100% accurate as into the current state of the code. In addition, lectures don't really leave a very accessible reference. It's really hard to get afterwards to retrieve some knowledge that was transferred during the lecture. For example, if you do have a video file, you would have to start scrolling around and trying to find all those things you wanted to get from that lecture, and it's really hard. It's not like text that you can search, for example. In general, lectures are important, but they mostly help in covering high-level details. So architectural decisions, for example, the big design decisions, the why, the business logic. For these things, lectures are really good, and they also usually depict things that are not changed very frequently. So lectures do have their place, like clean code. But again, lectures don't tell the whole story. And if we do transfer knowledge only by lectures, it means it's going to take us a lot of time. Another way is docs, documentation. So some people write documentation within the code. That's something else. We'll talk about it soon. But you could write documentation on an external platform. It could be Google Docs, it could be a wiki, or any other platform. So when you write docs, there are a few challenges. The main challenge, in my opinion, and one of the cases I'm going to take here, is that documents are decoupled from the code. So you have the code and you have the documents. By the way, if the documents live within the repository, it still doesn't mean they're coupled to the code. It's still just text, even though it lives alongside the code, which means that when the code evolves, and as you know, software always evolves very fast, then as the code evolves, the documentation gets outdated very quickly. As a result, we get documentation that is inaccurate, as in it doesn't reflect the current state of the code, and then we may not even want to read it in the first place. So basically, to avoid that, what happens very frequently is that developers only create fluff documents. That is, documents that describe general notions, again, high-level decisions, not things that actually give us the actual practical knowledge we also need as developers to actually get our job done. Okay, so what can be done about it? Well, before we jump into that, let's remember the docs are also scattered. You can't find the document you need right when you need it. Sometimes in current companies, for example, you would find that knowledge is scattered over documents in Google Docs, and some of it is in some email correspondence, some in the Slack message, some knowledge is in code comments, some is in some lecture, and overall you get this feeling of lots of knowledge pieces that you can't retrieve when you need them. So if that's the case and everything is so broken, we can ask ourselves, why bother create documents in the first place? I mean, if I get to read a document and then I just realize, oh, I actually needed that document a month ago, but I didn't find it when I needed it because the knowledge was scattered. And also, it is outdated. So why would I get into the trouble and effort of creating a document if I know it's going to become outdated and not found when needed very quickly? So another thing we need to take into account is that when people talk about documentation, they usually talk about either low-level documentation or high-level documentation. And by low-level documentation, what I mean is code comments. So actual pieces of knowledge that are written as text within the code. So this here is a very extreme example of very bad comments. So for example, this one says, this is where the function starts. Obviously, this doesn't help me very much. Also, var I equals 0, initiating the index also doesn't help me very much. And there is a lot going on in a lot of forums where people discuss what good comments are and what they aren't. Now, comments can be a great tool to explain something in isolation. If I divide a variable by 24,000, for example, I would probably need to explain why I do that. And for that, a short comment is a great way to go. Also, to explain a function, why it does what it does, and the parameters it gets, it's really good to leave some comments. But in nature, those comments are very low level, as in they explain only this part of the code in isolation. They do a very good job in that, but even if they are carefully written, they can't describe the bigger picture, flows, and so on. Another kind of document is the high-level documents. For example, describing the main architecture of the software system we're describing. These documents are really important. They give you the high-level overview that is vital to know when you start contributing to a project, for example, but they're not the whole picture. You need a lot of details that are more specific than that to be able to actually contribute to the system. You need to know how to do things, not just in very general terms what the system looks like. So, to recap what we've covered so far, we talked about 4 different ways in which people can try to share knowledge. So one way would be the good luck approach. The good luck approach basically means I'm throwing you into the water and please try to swim and not sink. So this is obviously possible, but it's very not optimal. So it takes a lot of time, both from the people who get thrown into the water and also from the people who are there to guide them along the way when they have questions. Another approach is clean code. And as we said, clean code is definitely important, but it doesn't tell the whole story. It can tell the story of code in isolation, but not the story of code in a broader term. When we talk about lectures, we mentioned that lectures take a lot of time, especially if they're not recorded. And if they are recorded, they get outdated very fast. And in general, they're effective in conveying the high-level image, the high-level picture of the system, and not how to get things done. And we mentioned wiki or documents in general, and since they are decoupled from the code, they get outdated very fast, and also they don't get you find them when you need them. So you may find yourself getting to a document and then thinking, oh, I really needed that a few weeks ago, but I wasn't able to find it when I needed it. So another claim I would like to make is that developers need and deserve good documentation. Okay, just like developers need a keyboard to work, just like developers need their screens to work, developers also need and deserve good documentation that helps them accomplish their goals. And the problem is that documentation nowadays is completely broken. So just to iterate that again, creating documentation takes time. It also takes effort. And then, since it's decoupled from the code, it gets outdated when the code evolves. So it's hard to find when you need it. And in general, if that's the case, why bother creating it in the first place? So this is basically a vicious cycle where you have someone finding documentation, then thinking, oh, it may be helpful. Oh, actually, I needed that a while ago, and also it's outdated. So why would I bother in creating good documents? So maybe I'll just write fluff documents, and then someone else reads that document and says, okay, this documentation doesn't really help me. And all in all, it's a vicious cycle where people lose trust in the documentation. So in order to change that, what I'm going to propose is a notion called continuous documentation. And we actually wrote a piece about that in InfoQ as well. And basically, continuous documentation calls for creating, maintaining, and finding documentation within the development workflow. So basically, what we want to get is documentation that is practical for developers, not only fluff, very general documentation that is also important, but we want the practical things, how to add a certain type of class to the system, how to configure something, how to change a value, how do I, and fill the blanks. So we need practical documentation that is easy to create, it's easy to maintain, that is, keep it up to date, and also easy to find when and where you need it. So that's the goal. The very first block that we need to establish for that is to make documentation code coupled. And by code coupled, I mean a document that has text. Okay, so we see text here, but we don't only see text. So we see text. Let me mark it here. So we see text, but other than the text, we also see references to the code. So here we see a snippet, actual lines from the code. We also see a token. So this 100 you see here, this value right here is the 100 from line 46 right here. And also we see paths like this one here. It could be a file, it could be a folder. So we have these references to the code And these references are actual references in that they stay linked to the code. It's not just copy pasting the code, but it's an actual reference. So the very first step is to have documentation that includes those references to the code. One thing that it allows us is to get very practical documentation because it actually describes the code, right? So if we see, as an example, a document that explains about configuration in this repository, for example, you can actually see what it looks like in the code alongside the explanation. This is very practical for developers, and this is documentation that as a developer, I'm happy to read. Now, the problem with this kind of document is that it's going to get quickly outdated if we don't do other things. So what can we do about it? Now, since the document is code coupled, we can also make sure that it's up to date. And I'm going to show you soon how we do it with Swimm, but this is a general notion as part of continuous documentation. So to make sure documentation is always up to date, what we do is we check the documentation and the code continuously on every pull request. And then if the code changes, we want to update the documentation accordingly. So just like we do with test, right? Every time we push a few changes, we create a pull request, then all of our tests run and make sure that the code still accomplishes what it should accomplish. Now, we suggest also adding another kind of test, which validates that the documentation is up to date. And we can do that because we referenced the part of the code that the document describes. So what is left for us to do is actually verify that those parts of the code that were referenced in the document are still relevant, they haven't changed, or if they changed, update the document accordingly. This is again possible due to the fact that the documentation is code coupled. And it's continuous, just like continuous testing. So we can do this on every pull request, we can do this on every push, we can do this whenever we decide. It could be pre-commit, that's up to us to decide. And let me move my face again. Cool, so it's a part of the development workflow. It's something you can achieve during your work and not something you do every quarter or every few months when documentation is already outdated. So how can that happen? What could it really feel like? So let me show you how we accomplish that with Swimm. So here is an example of a document, exactly the document I just showed you before. It's a very short document. It consists of 3 snippets, and it shows how to add a value to the configuration in this open source project implemented in Python. So in this case, it shows us 3 different snippets, one from each file. The first one in config.py, and you can see the value here, victims max find. And then you can see that in monkey.py, they actually use this value, and the snippet I showed beforehand in the presentation, we can see here the lines of code in an internal.py file where you define a schema for every value you add to the configuration. In this case, it consists of title, type, default, and description. Okay, so we have all of that. And now, let's say someone pushed a few changes to the repository and they created a pull request. So this is a pull request that changed some of those references. And we have a GitHub application that leaves a comment on the pull request telling you that 12 Swimm docs are still up to date, but 1 doc is outdated and it needs your review. So if I click on review an app here, I will actually get to Swimm's platform again, which will show me what I should do for every snippet. And we differentiate between various cases. So in this case, the code we reference from the file monkey.py hasn't changed. It remained like that just as it was when we created this document in the first place. So it's up to date, and I don't need to bother myself with the question of whether the documentation is up to date or not. Another case is this snippet right here that changed, but changed in a way that we still consider to be consistent with the documentation. So in this case, for example, what used to be lines 43 through 48 in a file called internal.py now moved to new file name.py, lines 49 through 55. There is a new field here called the version field. The default value changed, but all in all, it still seems like the same snippet. So we auto-sync it for you. We allow you to just click accept and accept this change or select another snippet instead. Similarly, we also auto-sync the token. So what used to be the value 100 in line 46 in the file internal.py is now the value 1337 in line 53 in newfilename.py, and also the path here changed. So we have all of these changes that we're able to auto-sync in case there are small changes. But some changes are not like that. Some changes are huge, breaking changes. In this case, what we do is we mark this as outdated. We don't show you the code in its current state, but rather what you mentioned when you created this document. And in this case, just for the sake of the demo, we erased the original line and we wrote instead something different, Swimm demo. Okay, I won't hide it here. So something different, Swimm demo is obviously different. It changes the meaning. So we need to create another snippet or maybe remove it from the document. So the general notion here is that we do that on every pull request continuously, which allows us to make sure the documentation is always up to date on every pull request. And that's different from, let's say, going over all of your documentation every few months, which will be cumbersome, hard, and the knowledge is not fresh on your mind when you need to update it. And also people will stumble upon outdated documents. In this way, we ensure documentation is always up to date. Okay, so this helps us know that documents are always up to date. Now, some things to learn about Git, and usually when I give presentations, even about general notions, I like incorporating some technological details that are interesting. So in this case here, I wanted to describe a bit the internals of Git. And if you're interested in more about that, you can write me later. I'll send you some more resources. We've written a lot about it. So in this case, we see a commit history, right? So what you see here is the master branch, or it could be a main branch or a default branch. And then we have a feature branch, and there we merge it into master again. But what happened since then is that at some point, this commit changes the code, right? So what we can think about doing is that, remember, within the document that all the docs were up to date in this point of time, and now we need to check on the pull request if they are up to date even here in this point in time. So I think the way that usually comes to mind when I talk to people about it is store the commit SHA, right? So we know every commit in Git has a SHA-1 value that corresponds to this specific commit. So we can say, okay, this commit used to live here, and in the state of the code in this commit, this document was up to date, which is cool. We can always then look at that commit, look at the current commit, compare them, and figure out if the documentation is still up to date or not. So this sounds like a very good idea. But if we think about it more carefully, we will find out that it's not always the case. And the problem is that sometimes commits get erased. How can that happen? Well, someone can rewrite history, for example, using an interactive rebase, and then using push force, and this commit would be erased. In this case, we won't be able to reference this SHA-1 value we had here, or at least the commit that it represents, because this commit no longer exists. Someone erased it. And in this case, we would get into a problem. Now, you may want to say, okay, this is an extreme case, but actually this happens all the time. Many people use force push. Many people rewrite history. So we may get to a situation where we cannot rely on the source commit. So what can we do? So to understand what we can do in this case, I would like to take a small detour and explain a bit about the internals of Git. So just a little bit. And again, I think the internals of Git are fascinating. And if you want to learn more about it, please reach out to me afterwards. So how does Git work? Basically, we can think of Git as a system to capture the snapshots of a file system. So like you have a root directory on your file system on your machine, and it consists of folders and files. Git stores various versions of a specific file system that we call a repository. Now, the equivalent or almost equivalent of a file in Git is called a blob, binary large objects. Blobs can be binary, so consist of binary data, or textual data, which are, of course, also binary. And we can perform SHA-1 a hash function on these values and get to the SHA value that represents the specific blob. So a file in Git is a blob, just chunk of data, just a stream of bytes, and we can compute a SHA-1 value for them. So this is a blob. Notice that it doesn't contain the name of that file. So it could have two different file names, two different files, if we're to think about it, that actually have the same content. In Git, they would get the same blob, so Git doesn't have to store it more than once. If in a file system we have folders to put files within them, in Git we have an object called tree. So a tree can include other trees or blobs. It's basically a directory listing. So here it says the blob with a SHA-1 F92A0 has the name pic.png. So this said this is a file name pic.png, and the blob, which has all of its contents, is the blob with the identifier F92A0. Now notice I'm using only 5 characters here, just not to take too much space, but obviously if you look at the SHA-1 values produced by Git, it's 40 characters. So another file you have here is go1.txt with a SHA value of 73D8A. And a tree can consist of other trees. So this folder here that also has a SHA-1 value, so I can compute SHA-1 of this dir structure and get to the value cafe7. So now I have another tree that has a reference to this tree. So I have a tree, and within this tree, I have a subtree, which is another folder. So to use that, we say here we have a tree, not a blob, but a tree with the blob, so with the SHA-1 value of cafe7 and the name of docs. So we actually have a directory called docs, which in turn has 2 files, pic.png and 1.txt. And we see that this tree also has a blob, so the one with the SHA value of food1, a file name called test.js. So again, the equivalent of that structure would be a folder within a folder. So we have the main folder here. We don't know its name. We have this folder here called docs with 2 files, and we have another file called test.js within the main folder here. Now, to create a commit object, what Git actually does is have a tree it references. So in this case, this tree is the root directory. So the commit references the root directory. And basically, a commit is just that. It's a snapshot of the entire file system in time. So from the commit object that includes also metadata, just at the parent commit, in this case, we don't have a parent commit because it's the first commit, the author name, a message, timestamp, and so on. So we have this metadata. And importantly, we have a pointer to the specific tree, which can then be used to recursively get to the entire file system structure. So now let's say I'm making another commit, or I'm making some changes and going to commit them. So let's say I changed a single character. I took this file here, 1.txt, and I changed it to be hello world, and then an exclamation mark. So I added a single character. So what is going to change now? So actually, this file, 1.txt, or more accurately, this blob is now a different blob, right? We have a blob that consists of one more character. And as a result, its SHA-1 value is going to be different. So it's going to be 62E7A, for example. So let's say I have this file now. It has a different blob. But if this blob is different, then we would also need to update the tree object, right? Because the tree object references this blob. So this value here is going to change because it references the new blob. As a result, the SHA-1 value of the tree object also changes. Now notice that we don't need to change the SHA-1 value of pic.png. The blob hasn't changed. So Git doesn't need to store this blob again in its file system, in its internal object directory. And again, if you're interested to learn more about how this directory is built, you can reach out later. So in this case, we see that as we changed hello world, the file 1.txt, we created a new blob. So the blob SHA of this file changed. As a result, the blob SHA of the tree changed because we need to change the directory listing, but we didn't need to store this file again. So we don't store the entire file system each time. We do store a snapshot each time. And since we changed this value, then of course, also the tree that points to it need to change. And again, we didn't change test.js, so we don't need to recreate this file, but we do need to create a new tree object for the root directory. So it has another SHA-1 value, and we can create a commit object where its tree points to this tree, the new root directory, and it has the parent commit, which is the previous commit object. So to recap, in Git, files are blobs. Well, kind of, because they don't really contain the file names and so on, but the contents of files are blobs. Folders are trees that are basically directory listings that contain either other trees or blobs or both. And commit objects are snapshots in time of what the file system is like. And to do that, it actually contains a pointer to the tree representing the root directory. Cool. So now we know how Git works under the hood. So how is that relevant to our case? So to remind you, we had this problem. We created a few documents, and we implemented code, we created documents, we pushed them. When we pushed them, we had this commit, and then we used force push. And the force push actually erased this commit from history. Can we do something else, perhaps? Instead of relying on this commit, if we know that commit values don't exist. You can write answers in the chat, perhaps, if you want to. If we have any ideas. Okay, so basically, what we can do, we can indeed rely on that value right here. And instead of relying on the commit SHA, sorry, I didn't change the slide. So instead of relying on the commit SHA, we can rely on the blob SHA of that file, because even if the commit object no longer exists, the blob that it referenced is another object that should still exist and should be reachable for us. So this is something we can do to actually rely on file blobs instead of relying on commit values, because they're more consistent or reliable, and we can count on them to exist. So we said we wanted documentation that is practical. So we get that from code couple documents, because the documents actually contain code, right? So they are very practical, that are easy to create. So I can say that by starting from the code and looking at code snippets and tokens and so on, rather than just writing text on a blank page, but starting from code actually make things work much easier. So it's easier for me to create documentation this way. And it's very, very easy to maintain. As we've seen, we can monitor changes on every pull request and suggest changes automatically and update the documentation. Now, the missing bit is that we need it to be easy to find. And also here, we can rely on the fact that we have code couple documentation, and we can show you that documentation when you need it. It could be in GitHub. For example, when someone makes changes to a file, we can say, oh, this file is referenced in this doc. Maybe you want to view those files as well, and also from the IDE. So let me show you an example of what this experience can look like. So for example, in VS Code, what you see here is actually the file from the open source repository we looked at earlier. Let me zoom in for a bit. Cool. So what you can see here is that I look at this file, and we have a plugin that actually shows us that there is a document that references those lines exactly. If I hover on that, I get the title of the document. And if I click right here, I get this file opened right from the IDE. So I'll be able to see the document from the IDE without needing to context switch. So this way, we can also find documentation when we need it. We don't even need to search for the documentation. We just browse code as we do while we're trying to understand code. And then we see, oh, there is a document that can help us understand that. And again, we can do that as a result of having the documentation code coupled, importantly. So if we get back to the story from the beginning, what that junior waiter actually needed was to have a result right in his IDE. And more seriously, I really don't have a solution for waiters and their onboarding processes, but I think for developers, this is really something different. Because with continuous documentation, we get practical documentation, as it it is code coupled. It is easy to create since it's code coupled, and there are other ways. I'll elaborate on that very briefly in a moment. It's easy to maintain because you can auto-sync your documentation in pull requests, track the changes, and update the documentation accordingly. And it's easy to find from the IDE or from GitHub or another Git hosting service. So still, there are more challenges we're facing. We haven't really solved everything. One challenge is beliefs that people have about documentation, because many times when I talk with people about documentation, they tell me, I don't believe in documentation. And to be honest, I can understand that. I don't believe in documentation in its original form either. I mean, after all, if it gets outdated, if you can't find it when you need it, really, why bother create it? So I understand why people don't believe in documentation the way they're used to, but we need to understand that with continuous documentation, we're really talking about a different kind of documentation that is worth investing in. Also, documentation is many times low on the priority list. It's considered as something that is not as urgent as fixing bugs in production, for example. But I think as modern systems become more and more complex, the importance and urgency of sharing knowledge in an efficient manner really raises. And we have more and more people joining new teams, people working remotely and not being able to ask their teammates in a minute, just, hey, can you please help me with this part right here? Because people may be unavailable at the moment or in different time zones, or maybe someone who knows the answer already left this team. So all of these reasons make it much more urgent to invest in documentation as long as it makes sense. And continuous documentation changes the world in the way that it works with documentation, so it does make it worthwhile. Also, developers don't necessarily like writing. I mean, as developers, we learn to write code, not text. We didn't choose, well, most of us at least, didn't graduate in, poetry or essays writing or something like that. We usually do computer science or bootcamp and learn to actually write code. So one way to help with that is to really help developers creating documentation. And to understand how we do that, we need to first understand why it's right to hard good documents. It's hard for three main reasons. First, it's hard to determine what we want to document. So what is even important to document? I mean, let's say I look at a repository that consists of 20,000 files. How do I start? What's important to document and what is not? Let's say I know about a specific concept in the repository that I want to document. Then how would I write a good document about it? What would a good document look like? As a developer, I don't necessarily know how to do that. That's not my profession. And in addition, even if I know what I want to document and I know how to write a good document, still investing the time in writing the document is still costly. It still takes time to write a good document, right? So in order to help with that, we've been developing something new. We call it Swimm generated docs, where you can connect your repository to our system. We use static analysis to analyze your code base, define what is important to document, and generate documentation for you. And I think this kind of tool or this kind of approach will really be beneficial in helping developers create documentation more easily, as we will help creating documents for them, or at least skeletons of documents for them. So this is another thing we can get from code coupled documents, and this is a way to actually generate code coupled documents automatically, since they're generated from the code, and we can use, again, static analysis or other analysis processes to generate the documentation. In general, I would like to say that the way we share knowledge on code, about code, has to change. It doesn't make sense that even now in 2022, we still have those problems where it's really, really hard to share knowledge about code. And we use the same techniques we used to have 10 years ago and didn't work then, and they still don't work now. Now we have the tools, we have everything we need, we have the technology in order to share knowledge in a way that makes sense. And I think we owe it to ourselves, to the developers community, for new developers who want to join the community and contribute more code. And also, I think another thing you can take from here is that good ideas come from drinking a lot of good coffee with good people. Highly recommended as well. Okay, so at this point, I would like to see if you have any questions or comments or something you would like to raise about any part of the presentation. And thank you very much for the nice comments. I would also say that feel free to reach out to me. My email is Omer, Omer, @swimm.io. Feel free to reach out to me if you have any other questions, any thoughts about documentation, about knowledge sharing, about Git and its internals. I would be very happy to answer. So thank you very much for joining me today. And I wish you all a great weekend, evening, wherever you are. Bye.